You've got this super smart AI, right? Like a search engine. But how do you make it even smarter, especially when it has to deal with us, real, unpredictable people? That's the big puzzle we're going to dig into today. So picture this. You've spent months in a lab crafting what you think is a perfect algorithm. It's flawless. But then you release it into the wild, and the moment it meets the real world, things can go sideways in ways you'd never expect. And that, my friends, is exactly where our story kicks off. Okay, so every new algorithm has to start somewhere, right? And that's usually in a nice, safe, controlled environment. Think of it like a training ground. It learns from old data, gets tested, all before it ever has to face a real person. This is its first big test. And, there's a really good way to think about this. Building one of these learning to rank models, and that's just a fancy term for the thing that decides the order of your search results, it's a lot like training a self-driving car on a closed test track. On the track, everything's perfect, predictable, the car learns the ideal path, no problem. But that's a whole different ballgame from trying to navigate a real city during rush hour, isn't it? So in our story, we've got two main players. On one side, we have LTR model variant 1. Think of this as the old guard, the current standard model that's already out there doing its job. And on the other side, we have LTR model variant 2. This is the new kid on the block, built with way better features. Everyone's betting this one is going to be a huge improvement. And, well, in the lab, variant 2 is an absolute rock star. I mean, look at this. For searches like Dark of Moon or Transformers DVD, it's not even a contest. The new model is just blowing the old one out of the water. Based on these numbers, you'd be popping the champagne, right? You think, yep, this thing is ready to go live. But this is where things get interesting. This is where our story takes a hard left turn. Our star pupil is leaving the clean, pristine lab and heading into the messy, chaotic real world. It's time for the final exam, with thousands of actual, real-life users. And that final exam, it's something called an A/B test. The concept is pretty simple, actually. You take a big group of users, and you randomly show half of them results from the old model. The other half, they get the results from our new, supposedly smarter model. And the real judge here, the ultimate measure of success, it's not about clicks. It's about what really matters, actual purchases. Okay, get ready for this. Here's the big twist. For that search, Transformers DVD, our brilliant new model actually led to fewer purchases. Seriously. The old model, the one it was supposed to replace, it drove 21 sales. The new one, only 15. This is the exact opposite of what all that lab data told us would happen. So, what on earth happened? The model was a genius in the lab, a straight-A student on paper. So why did it completely bomb its final exam when it met real people? Well, the answer is this really subtle but incredibly powerful problem in machine learning. It's like an invisible echo chamber. And our brand new algorithm, it was trapped inside it from the very beginning. This sneaky problem is called presentation bias. And here's how it works. It's a vicious feedback loop. The model learns from what you and I click on. But we can only click on the things the model decides to show us. You see the problem? The model can get totally stuck just showing the same old stuff, and it never discovers potentially better results because it never takes a chance and shows them. It's the ultimate chicken and egg problem, right? The model only learns from our clicks, but we can only click on what the model shows us. So what happens to a potentially great result that's buried on page 2? It's never shown, so the model can never learn that it's great. It's completely trapped by its own very limited experience. So the big question is, how do we break out of this loop? How do we fix this? Well, we have to teach the algorithm to be curious. We literally have to build a system that knows when to stop playing it safe and start exploring some new possibilities. And this brings us to a really core concept in all of AI. It's called the explore versus exploit trade-off. Think about it. Exploit is when you just stick with what you know works. You show the safe, predictable results. It's the safe bet. But explore, that's when you deliberately try something new, something you're not sure about, all in the hopes of finding something even better. It's a constant balancing act. So how do you get that balance right? Okay, imagine this. You're a scientist and you're planning to survey a river that's rarely been explored. You have a little bit of data about its depth here and there, but there are huge gaps in your knowledge. How do you decide where to take a measurement to learn the most without taking a huge unnecessary risk? That's where a really cool statistical tool called a Gaussian process comes in. Here's the magic. It doesn't just predict what might happen. It also tells you how uncertain it is about that prediction. So just like our scientist, this lets the search engine find its own blind spots, the areas where it's basically guessing, and then take smart, calculated risks to go learn more. And guess what? Using this very method, the system found a massive blind spot for our Transformers DVD search. It realized it had almost zero data for a really important feature, has promotion. Why? Because the old model almost never showed items that were on sale, so the new model never had a chance to learn just how much users might care about promotions. And that discovery, that was the key that unlocked everything. Now that the system knows it has a blind spot, that it needs to learn about promotions, it can finally build an automated loop to make itself smarter and smarter over time. So that's exactly what it did. The system started to explore by deliberately showing some users promoted items for that search. It collected all that fresh feedback and used it to train a brand new model, LTR Model Variant 3. And this new model, it gets something its parents never did. For this specific search, promotions are a huge, huge deal. And the results? Oh, they are absolutely dramatic. They run a new A/B test, pitting this new Variant 3 against the original model. And this time, it's a total landslide, a blowout. The new model drives 145 purchases, compared to the original's 21. All because it dared to explore its own blind spots. This system became unbelievably more effective. But here's the really cool part. This isn't a one-time fix. It's a continuous, self-improving loop. It's simple. First, you exploit what you know works. Then, you intelligently explore what you don't know. You gather up all that new feedback, and then you repeat the whole thing. The system is literally designed to get smarter and break out of its own echo chambers, cycle after cycle. And that leaves us with one last big question to think about. We've seen how this can break a search engine out of its echo chamber. But what about all the other AI in our lives? You know, your social media feed, your movie recommendations. Are they also stuck in their own little bubbles? And just imagine what they could become, what they could show us, if we just taught them how to explore.